Hello, everybody. My name is Lumir Janchev, and I'm the CEO of MClimate. The reason for this webinar right now is to do a relatively deep dive down into one of our LoRaWAN products called Vicki, which is a radiator valve. I'm gonna talk about our company in the beginning for about 5 minutes. So if you already know our story, what we offer, feel free to skip the next 5 minutes. And I'm gonna share my screen right now. So yeah, the webinar. The idea behind it is that Vicki, it's a relatively complicated device. Compared to the current available devices on the market that are a LoRaWAN, Vicki is different because it's not only a sensor, but it's also an actuator. The idea is to control the heating in a room or in a whole building. But we're going to get to that. So let me tell you a little bit about our company. We started in 2015. We're incorporated in Sofia, Bulgaria. We're actually a smart home company. We started as a B2C company, and our goal was basically to, allow people to take advantage of the home automation, feel the comfort of it, but in the meantime, to drive down their costs for. Okay, I just want to check. Okay, the recording is still going. So yeah, the idea is to offer devices that are enhancing their comfort, but in the meantime are in the background saving them energy. Why we want to save energy? So of course it's important for the customers. But when we have tens of thousands of those devices in so many countries, you can really see the footprint that we're able to solve, able to save, yeah, this is our reason behind it. Because right now energy is used pretty irresponsibly. People, for example, are running the heating but are opening windows at the same time. So as we say, automation is not privilege of a few, but rather the right and social responsibility of all of us. So yeah, our products, most of them are really B2C, meant the customer is in our DNA. We're thinking about the customer from the very first stages when we're designing the architecture, thinking about the industrial design of the product, how it's going to be used, should it have a screen, or for example, only the application is enough. So far we've got about 20 products on the market. We started with Wi-Fi products in the beginning because we didn't really want to have anybody purchasing their own gateway. But with time and the development of LoRaWAN, we started creating LoRaWAN devices. The first device was actually Vicki, and we do have a version which is not LoRaWAN. It's a proprietary protocol based on the same chip from Semtech, but it's not speaking LoRaWAN. And then once we started going outside of the smart home and in smart buildings, this is when we recognized that we should definitely put some effort in, some new devices, LoRaWAN devices on the market, but also making our existing devices available under LoRaWAN, not only the Wi-Fi. So yeah, we have a production facility here in Bulgaria, not in the capital, but about 200 kilometers away. We are selling in a lot of markets, and yeah, we've been named Startup of the Year by the Bulgarian Investment Agency back in when we're starting, and then later we joined Endeavor. And this is a little bit about our timeline. Basically, we started 2015. Our first product was Melissa, which you can see on our website. It is a device that controls all types of air conditioners that have a handheld remote control. Then we started developing Bobby, Vicki, Maya, And you can see all of our products on the web page. But right now we're here. We raised some money along the way, but we're a cash flow positive company for quite some time now. And yeah, it's interesting what is actually ahead, not what has happened. But as I said, we're manufacturing in the EU, which allows us to be really flexible, so we can maintain the manufacturing quality at a really high standard. Most It's also an advantage that the labor in Bulgaria, it's not as expensive as in other countries, but in the meantime it's an EU country, so we can ship freely to whole Europe and actually pretty easily to the whole world. The other thing is that as we're coming from the B2C world, we're trying to maintain affordable prices for our products. In the meantime, we're a pretty small team, but we've been working together almost since the very beginning with all the people there, which is something I, as a CEO, am really proud of. Right now, working with so experienced people really helps us grow even faster. But yeah, enough about that. So as we were in the smart home industry, this later we basically transferred or opened in 2019-20. We opened another vertical for us, which is not only smart home but also smart buildings. So far we have devices, especially Vicki. Vicki is in a lot of buildings. Let's put it this way. A lot of residential buildings around the world, but also some obviously offices, some houses, some also shared spaces like co-working spaces, offices and buildings. We've got some municipal buildings, even some with very high security. But basically, what we're able to offer for this smart building world, it's divided in three main things. So first of all, it's energy efficiency, because we want people to get return on their investment in the beginning, and in the meantime, we want to actively save energy. Obviously, things around us are crazy right now with the health crisis, but I'm pretty confident that unfortunately at some point we're also going to be facing environmental crisis if we're not already. So this is why we have the device Vicki LoRaWAN, and another device which is an indoor temperature and humidity sensor. Then for the water control and damage prevention, we have a product called T-Valve, which is basically a water shut-off valve. You can, turn on the water supply or turn it off. It's certified for drinking water, and it's really nicely combined with our flood sensor. So the flood sensor, it's a small device, again, a battery-powered device with a long lifetime of the battery. It can be installed, for example, in some wet rooms, near the kitchen, under the kitchen sink, for example. But the idea is that whenever the flood sensor senses a flood, then it instructs the T-valve to basically shut off the water until you get home. Because obviously it's one thing to catch a flood on its second minute, and it's another thing if you come home and everything is flooded. And then the last kind of section that we have, it's the AQI sensor, as we call it, air quality index sensor. It's actually not only a sensor, but a notifier as well. So this product is, as I'm recording this seminar, this webinar, it's still in its last stages of development, but we're going to release it really soon. So the idea there is it's measuring temperature, humidity, CO2, AQI, VOCs, pressure, and also it has a small buzzer inside, as well as an RGB LED. And the main application here, and why we did it is because of the whole health awareness and people going back to the office. And we really wanted to make something that is not only, you know, projecting things on a dashboard, but rather can actionably notify somebody in the room if the room needs to be ventilated. Because obviously there is this relation between CO2 and the chance of virus transmission. So, and obviously, I mean, if you are a couple of people in a room, you don't ventilate the room, the chance of transmitting a disease is higher. So basically, the AQI sensor it's logging the data, but then you can configure it so that whenever people need to be notified in some manner, either acoustic, it's really discrete. I would say it's really configurable. The buzzer, you know, it's not like a fire alarm. We're actually joking in the team that you can even make some melodies with it because it's really configurable. And then it also has the RGB LED, just in case that somebody doesn't like the acoustic alarm, but it could be like a single beep, like beep, something really short but noticeable. And last but not least, we're cooking some things in the kitchen, some new devices. So if you want to stay in touch with us, definitely you should subscribe to our newsletter on our webpage. But we're also open to developing devices for in cooperation with different companies. And for example, the T-Valve has been developed exactly in this way. We partnered with a big utility company. It's a global utility, great company that basically wanted to have such a product for their own business needs. And you know, we went from everything from research to, you know, the pilot, the first couple of pieces, the proof of concept, all the way to industrial design, incorporating into manufacturing and certification. So yeah, if you have any ideas about partnerships and new devices that you think going to contribute to the market, let us know. And here today, I'm speaking only about LoRaWAN, thinking that everybody knows what LoRaWAN is. If you don't know, I encourage you to go and research it. But it is a great technology. You know, with two just ordinary batteries, you can have a device working for like 5-10 years, which is I would say pretty significant. I mean, it allows a lot of business cases to be spun out of that, and also, I mean, the communication distance it's very very great. It's I mean, even indoor penetration is really good. So with a single gateway, you can cover a whole like a residential building with, let's say, 60 apartments. Yeah, but if you don't know what LoRaWAN is, I encourage you to go research it and then get back to the video, because I'm not going to be going into a lot of details about that, and I'm going to be using some words that are definitely you should know the protocol. So I'm going to share my screen again. Okay. And what is the table of content? What are we going to be talking about? I'm not sure if this was 5 minutes. Excuse me if you had to scroll. So yeah, first we're going to talk about what is Vicki, what does it do, how does it work, and compatibility with heating systems. Then we're going to cover the main principles of taking the device, commissioning it, decoding the Keepalive information. The difference between the different operational modes. And then we're going to also focus on the additional functionalities that really make, the way that we develop our devices is really, we want them to be as configurable as it can be from the outside. So we try to, expose everything with commands. Yeah, we're going to get to that. So, yes, what is Vicki? So Vicki is a smart radiator thermostat. It allows people to control their heating from distance Could be from our own application of MClimate. It could be from an API in a different application. It could be, not going to a cloud at all. It could be just in a dashboard for the facility manager. But basically, any radiators that have those TRVs that you see on the top, it's called thermostatic regulator valve. Vicki is compatible with them. The ones on the bottom that actually are a lock shield valve, you have something that you turn there. Unfortunately, Vicki is not compatible with those. So, and I mean, if you have such, this is a very outdated technology. If you have lock shield valves that you believe are going to be controlling the heating well at your home, I mean, Vicki is going to save you a lot of money, perhaps more than 50–60%, because the lock shield valves are really not energy efficient. The TRVs are, but the TRVs are an innovation that is already like 20 years old. So it's definitely time for something new, something that it's appropriate for 2020. And LoRaWAN actually makes this possible. But so this is Vicki. This is Vicki on a TRV. I'm gonna show you. As you can see, there is a little spindle in a little shaft in the middle. This is the Vicki backplate. So this is the thing that you're mounting on the TRV. It's really easy to mount and demount, but as you can see here, focus is not real good, but okay. So this thing here, the small shaft that is really hard to push with a hand, it's actually controlling a valve inside. So water goes this way, goes out this way, and the more it's pushed down, the more the valve is closed and the less water goes. So you're going to be seeing this if you're doing a large-scale installation, for example, in an office building. You're going to be removing the old valves and then installing the new ones. So the removal, it's really easy. You just unscrew it. I don't think you're going to be needing any special instruments. And then the mounting kit's again really easy. You just mount it this way. You just screw it tight so that it doesn't move. And that's it. This is how it looks. So here is Vicki. Vicki, it has a QR code in on the front. It also has a display. You're going to see it in a couple of minutes when I put the batteries. And then on the back, you're going to see a battery compartment that you need to use, and the motor. So the motor is actually the thing that is controlling the valve. So on the battery plate, there are, I'm not sure if you can see them because it's not focusing, but there are a plus and a minus. And this is how you insert the batteries. Basically, open it, just push it up, then get the battery, put it inside. And by the way, we do recommend using Energizer lithium with the Vickis, and this is the batteries that we recommend to all of our partners and clients. And also, we've done accelerated aging tests with Vicki with those batteries, comparing them with other batteries, and the results are really different, I would say. But we definitely recommend you using those. So. Okay, I put the batteries inside, as you can see. I close this one, and then on the front it says hi. Okay, so now you know that it is powered on. And by the way, the dot on the upper side, it's actually a hole, but it is a temperature and humidity sensor. Because obviously, if you want to be controlling the temperature, you want to also measure it. So what you do is, you see this little thing here. It matches the other one. You basically align them and then just, okay, you keep the up part and you rotate it clockwise. So what is going to happen, a little animation. So right now the valve is actually closing. You cannot see it because of the TRV that we've used. But right now, Vicki is basically figuring out what is the amount of steps that the motor should do in order to open or close the valve. And then once it displays the target temperature, it closes the valve. This is the default setting for the commissioning. Let me share my screen again for a second because I skipped a little bit of the slides, but yes. So we inserted the batteries, we mounted on the back plate, on the valve, we mounted the Vicki on the back plate, and what happened is the motor calibrated, so it found the minimum and maximum range, and you know, so the idea is that the motor is on a specific position, but then the minimum is obviously 0, and then the maximum is found during calibration. Basically, it's unique for all the valves. So, and if you want to, for example, close the valve halfway, you set it to basically if the motor range is like 500, you set it to 250, and then the valve itself it's closed halfway. If you want to close it fully, you set the motor position to 500 equal to the motor range, which means fully closed. Depending on the operational mode that you're in, you might not actually care about the motor position and motor range. Why we've done it is because obviously we need it as engineers, but obviously, as I said, we're trying to expose basically whatever we can to you so that you can have greater control. So I'm gonna cover more about the operational modes in a second, but yes. So the next step is basically just let me show you. So when you turn it, it's adjusting the degrees, as you can see. So I can set it to, let's say, 30, and then Vicki is gonna figure out what is the temperature at the place, the humidity, and also going to control the motor to reach this position. We're also going to be talking about the algorithm that is being used for that, but this is going to be in a second. So I'm going to share my screen again, and we're actually going to go and configure. We're going to add this device to TTN, the Things Network. It's a great company. It's actually a community router where you have those free gateways that are installed in some cities. You should check if you have this in your city. But it's really friendly and easy to use, especially during testing. So what are we going to do is, so I'm not going to go into a lot of details about TTN. If you want to learn about that, I recommend you to learn to read their documentation. It's really good. But I already have a gateway set up, and I already have a couple of applications I'm going to open. The application I want, and then I'm going to register a device. So I've already copied the data about the device, but basically it has a name. So for the name, we actually recommend you to use the one on the sticker. It's a unique code that we generate, and but of course it's up to you. So then we have the device EUI, which is unique for every device, and you're gonna be, if you purchase devices from us, you're gonna be receiving this information as well for sure, so that you can commission them. Then we're gonna add the app key. We're gonna click on this, put the app key inside, and then select the app UI. This is already inputted in my application, but in case you don't have it, you have to go to settings and like input it. So, okay, now we have it up and running. What is happening? So Vicki is right now showing, let me just stop the sharing. Vicki right now, when you rotate it, is showing those two dashes on the top and the bottom. I guess you see them. So this is basically telling the end customer that the device is not currently connected to a network. And there are certain rules that we're going to cover later, but basically you can configure the amount of time that have the interval that Vicki should we try to connect to a network. In a case that, for example, you install, let's say, a hospital, and you know, the internet drops, and the gateway, LoRaWAN gateway, doesn't have any internet, so the devices disconnect from it, and then they have to reconnect. So there is some time, and there are some rules that we're gonna go later, but at some point, this device is gonna connect on the network. Let's see. Okay, the dashes are still there. But what we can do as well for the test is obviously open the device. Oh, just connected. Okay. But you're gonna see this is the shaft. It was closed, and right now it's actually opening the valve. Actually, the device connected right now. I have it on my background. I'll share my screen. Okay. So as you can see, there was a join request. Something happened like 25 seconds ago. We're gonna go to data for this device. Okay, I've been testing a lot before this webinar. But as you can see in 4:30, there was a join request. Perhaps because I removed it from the valve, this is why it didn't connect immediately. But okay, I'm going to show you now. Again, we remove the motor contracts. The motor is right now has opened the valve, but yeah, we open it. We're just going to rotate the device. It's not going to show anything, but this is how we're going to make sure that it's restarted. We put the batteries inside. It shows high. We close it. I'm going to share my screen real quick. Okay. To see that there was actually another join request here. Device is currently calibrating. Yep. So, I have to stop sharing. So as you can see, the dashes are not there anymore. This means that the device it's connected to the network. And then if I share my screen again, we're gonna take a look at a couple of messages. But what we see so far, it's only the join request. I'm gonna clear that, and now we wait. So the default setting of Vicki is Keepalive every 15 minutes, and the Keepalive basically sends all the vital information that you know, the sensors, what is target temperature, has been there, a detected open window, for example. But we want to wait a couple of seconds. I've set this Vicki to, I believe, 1 or 2 minutes just for the testing purposes and to make this seminar a little bit shorter. So, okay, I'm gonna pause the recording until we get it, or not. Actually, I'm going to open the presentation so we can talk about it. So we added it to the end. So yeah, I said about the Keepalive. So what is the Keepalive? The Keepalive is a message that the device frequently transmits every preset interval, including all the vital information. So what we've put inside Vicki, it's actually it looks kind of like that. I mean, if you take a look at the picture next to M0FV, it says payload, and then this is like the raw version of the Keepalive. Then there are scripts that decode it, and it looks like what it says on the field. So it can tell you the battery voltage of the device. It can tell you if there is a broken temperature sensor, if the child lock is enabled or disabled. We're gonna get into child lock later. Some technical data, high and low motor consumption, the motor position, so how open or closed the valve is, the motor range, so how many steps should be done in order to control the full range of the valve. If there has been an open window detection, relative humidity, which is measured, this is later converted, and then sensor temperature and target temperature. So yeah, we can set the Keepalive period using this command. And I'm gonna open also the documentation, because if you're planning on doing reinstallations with Vicki, then you need to know this document. This is the current version 1.6, but I encourage you to go through it to figure how Vicki works, what are the main principles, etc. But let's check the content, Keepalive, period set. So on page 7, and here it is. How do we set it? We type in 02 and then what the amount of minutes. For example, 02, 08 sets it to 10 minutes. So let's see if there's a Keepalive. Yes, there is a minute ago. And what it said is basically 3.2 volts, no broken sensor, no child lock enabled. The motor, the valve is fully closed because motor position equals motor range. Then we have the humidity measure, sensor temperature, so the measured temperature in the room, and then the target temperature. But if we want to change that, if we want to change the interval of the Keepalive, we can do that. By default, it's 15 minutes, and I encourage you to leave it there, especially if it's a residential building and not an office building where you need the heat really fast. But let's go and send a message, and it's going to be a confirmed downlink of set it to 1 minute. Obviously, it's not going to be 1 minute in reality, because we have to also adhere to the LoRaWAN standard. And in case that the spreading factor is 12, then there's going to be a message every 2.5 minutes. This is the maximum. Of course, we use the basically the as big Keepalive as you can work with, like 10-15 minutes, because this is really extending the battery lifetime. The accelerated aging tests that we've done are on 5 minutes, but this is accelerated aging tests. I mean, we've simulated 5 minutes. This is, for me, it's like too much, but perhaps some of you would like it like that. So exactly 2 minutes and 33 seconds later, we get a second Keepalive, which basically says, okay, target temperature 22, measure 28. So what I'm going to do here is actually get the Vicki. I'm going to get the Vicki and set it to 20. Actually, I'm going to set it to 30, just in case. But what this is going to do is basically you're going to see here in the next Keepalive how the target temperature here it's 30. Okay, so this command has been sent. Vicki is a class A device, which means that it's receiving downlinks whenever it sends an uplink. So yeah, we're gonna wait or no. Let's open the presentation again. And you got about a Keepalive. I mean, a message that is frequently transmitted on a preset period of time. And contains the most vital data, like measure temperature and humidity, how open the valve is, what is the target temperature, and also really important, what is the battery voltage. Not sure how important this, because if you use the recommended batteries, the statistics are showing from all the buildings that we've equipped is that Vicki is going to be live over well over about 10 years with the Energizer lithium. And as you saw, we actually set the Keepalive, as I said, to 1 minute in this case. But I recommend 10, maybe 15, depends on the case. If it's a meeting room, for example, in an office building, I would say 10 minutes is good. But then if it's like a residential building, perhaps 15 minutes are good. So let's move to the operational mode. So Vicki has 4 main operational modes. So the first one being, I'm going to start with the offline because it's easy to understand. So if there is a power outage in the to the gateway and Vicki cannot communicate to the gateway, then basically what she's going to do is you're going to be able to control it from the excuse me. You're going to be able to control it manually, but it's going to be using its own internal algorithm to control the temperature. And then the 2 dashes are going to appear. The first one, which is perhaps the one that you set up and just forget about, is the automatic temperature control. So what it happens is that you're only sending with the downlink, you're only sending to Vicki what target temperature do you want in the room, and then she uses its internal sensor to figure out what is the temperature there, and the algorithm that we're going to discuss later to reach that temperature. Then the second one, it's automatic temperature control, but with external temperature sensor, because in some cases, for example, public schools, they're very frequently like 3, 4, 5 radiators, and then you want to measure like temperature somewhere else, for example, and then base all those 5 radiators on single sensor temperature reading. So in this case, with the downlink command, you're sending target temperature and a sensor temperature. What is the temperature in the room? Then it's the manual temperature control. So the manual control, it's, I would say, for advanced users, it basically transmits, hey, I want you to display to the occupant of the room that this is the target temperature, but then I want you to drive the motor to exactly this position. So this is for people that are really into temperature controlling algorithms, that really want to tinker, figure out by themselves how to make it more efficient. Vicki, and we also offer that, and the way that you get the device operational mode, it's you send a command 18, then Vicki responds. So let's okay, actually we saw that we set the Keepalive, and then it started transmitting more frequently. Okay, so what happened here, and why is this downlink here, is that this this application, the MClimate, is actually connected to our cloud. And right now the cloud, Vicki, I guess it's in manual temperature control, the operational state, and then the cloud is telling Vicki, you should go to this position, because when the devices are interfacing with our cloud, we're also performing some machine learning there, etc. So we're learning the room, etc. But I don't want to get into those details. Let's check what is the state that Vicki is in. We send the command 18 as in the document, and then if we receive 00, it's manual control. If we receive 01, online automatic control, and 02, it's the same but with external sensor. And then here we can actually set the operational mode. So using command 0D, and then whatever mode we want to set, Vicki is going to react to that. But let's see if she answered. So she said 18, 00, and then 01, which is basically Vicki answered my command that I asked with 18 here, and then sent a regular Keepalive, just in case that you want to know all the information. As we can see, it's already on spreading factor 7. So let's set it to online automatic control mode. So by the way, the manual control mode is the default one for the device. And this is important to know, because if you are in manual mode, the device is not going to do anything by itself. It's going to be awaiting data from the server to which motor position it should go. But yeah, the command is 0D01 to put it into 0D01. This is going to put it in online automatic control. So we're only going to be transmitting what is the target temperature. So we schedule this command. And actually, I want to show you something else. So right now we saw that the target temperature is 30. Let's set it to something else. Let's try, okay. Also, I'm actually looking through this document. It's about 20 pages. It's not that long, but okay. So set motor position to update target temperature. This is in the case where we're using the manual mode, and set device target temperature. So page 13. We go to page 13 and we see that set device target temperature is 0E. So what we're going to do is go and send the command to set it to, again, I'm going to be using confirmed downlink. So 0E, the command code, and then we basically put the temperature in hex. So yeah, let's set it to 22 as it's in the example. So just, for you to see, I'm going to stop the screen sharing and show you that the device is currently on 30. Then we received a downlink just now. Let me share my screen again. We received a downlink just now. The uplink, excuse me. As you can see, the uplink is still 30. And then we set it to 22, and then the new target temperature is 22. And obviously, it's 22. Okay, I put it to 23 by rotating it, but it was 22. So let's move forward. Now you know how to actually about the operational modes. And if you have any questions, of course, you can reach out to us. Let me share my screen again. Okay. So what about the temperature algorithm? How does it work? What does it do? So it's not as complicated, but there are a couple of parameters that really make it configurable and allow you to have like a faster control or a faster temperature change in for example, a meeting room, or a slower change, let's say in the bedroom, for example. So there are a couple of parameters. So T-alg is basically the time that an algorithm passes, the period that this algorithm, the check of the temperature, passes each time, and figures out whether you should leave the valve at the same place, move it a bit open, or just close it a bit. Then there is the TDIF, temperature difference in warm and cold. It's called warm and cold because actually Vicki has two big, two main modes, like a heating mode and a cooling mode. Because in some countries there is also district heating. So this is the difference in temperature that has to happen in order for the algorithm to kick in. Let's say you want to maintain 25, and the TDIF it's 1 degree. So the algorithm is going to wait until it goes 24.5, 24.1, and then when it hits 24, so 1 degree difference between the measured and the target temperature, it's going to start acting. Then we have P first and P last, which is basically the amount of steps that Vicki, the motor, does in the beginning when it's fully closed or fully open. So if the motor is fully closed and you need to change the temperature, Vicki needs to change the temperature, it's gonna use P first or P last. And vice versa, if it's fully open, again, P first or P last. But if the motor is somewhere in between and the algorithm goes, then it's gonna use P next. Yes, let's take a look at this graph. So not sure if you see my cursor, But basically, what happens is first there is the plast. Okay. So first there is the plast as the motor was fully closed. Then we use pnext because basically the target temperature minus the measured temperature, it's greater than T cold. So it means that the target temperature has increased, and we need to heat the room. So we start opening that little by little at every T-alg interval. And then when we hit the, if the temperature goes above the target temperature, we start closing the valve a bit. And then again, for the last close, we use plast and pfirst. It's the same. This is why we have pfirst and plast and not like all the steps the same, because basically you can definitely set pfirst, plast, and pnext to the same amount of steps. That's fine. But if you want to have real fast reaction in a room, you can set like the pfirst and plast to something bigger than pnext and just have a faster reaction. So actually, we reached the additional functionality. So that's good. We're progressing. Gotta get some water. So there is a watchdog, it's called. Perhaps many of you know what that is, but it's basically a thing that can restart the whole wiki if something has happened. So we use that for the connectivity. So if, for example, confirmed uplinks are used and the device, so uplink from the device to the gateway, if confirmed uplinks are used and Vicki doesn't receive a confirmation, it's basically going to wait for 2 Keepalives plus a certain amount of minutes and then restart the whole device. So it's going to go through calibration just to make sure that we flash the firmware, we completely remove all the data from there and reconnect again. And then if unconfirmed downlink, uplink is used in the device, which, I mean, if you're operating your own network and you have, a gateway in a building, I myself for Vicki recommend you that you use confirmed uplinks. But if you have a lot of devices and the gateways are, having the hard time communicating with all of them, perhaps you're not staying in the duty cycle of the gateway, then you can use unconfirmed. So this is going to make the traffic going through the network less. But basically, the difference between confirmed and unconfirmed messages is that for the uplink, the Vicki sends a message to the network, to the gateway, and then when the gateway receives this message, it sends a confirmation back. Hey, I did receive this message. It's very white under this light bulb. And then if it's unconfirmed, the Vicki just sends the data and then doesn't request a confirmation. But yes, so those are the commands to get the device connectivity watchdog. So you just set 1D, and then it's returned the watchdog period for confirmed, and then watchdog period for unconfirmed. You can check this with the documentation as well. It's more interesting how to set it. So for the set, it's oh, I'm not sharing my screen actually. Excuse me about that. Okay, so we use 1D to get the what is the current setting in the device, and we use 1C to actually set it. And then we know with one message we set both the periods of confirmed and unconfirmed messages. But So the confirm, it's basically, as you can see, it's measured in minutes, and then it's, excuse me, it's measured in number of Keepalives. And it's with this formula, but basically this is the thing that you set, the x-axis, and this is time the Keepalive period. This is not a minus here, but let's say that the Keepalive period is let's say 5 minutes, then plus 7, this is a constant that we let there. But basically, if you set 1 here, it's going to be 1 Keepalive period plus 7 minutes. And then if there is no confirmation, restart the whole device. And the default value is actually 2. So, and default Keepalive is 15 minutes. So if the device doesn't receive confirmation for 2 Keepalives and 7 minutes passes, then it's gonna restart. And then for the unconfirmed messages, is basically a constant times 60, and the default value is 18, which it's actually 18 in the in hex. Let's see how to calculate that in. Okay, 18, 24. So 24 hours if you're using unconfirmed uplink. If the device doesn't receive any downlink in the meantime, even for temperature, target temperature set, it's gonna reconnect to the network. It's gonna attempt to do it because perhaps something is going on there. Yes, and let's talk about the network join retry period. Basically, this is a period where it really depends on the duty cycle and the LoRaWAN protocol, because there are some rules there about how often the device should communicate to the network. Because obviously, if you want to have a lot of devices running on batteries, all being served from just one gateway, then you want to have some rules there. So the network join retry period it's something else. If the device is not being able to join the network, so it sends a join request, but there is no join accept, then it will retry in some period of time. So this is also configurable. We recommend you to leave that by the default, but you can also control it. Just be aware that if you are if the device sends too many join requests and not manages to connect to the network, then it is going to wait for way longer, so up to 3 hours and something. So just be aware of that. But in case that, again, like the gateway is offline, there has been a power surge or whatever, but for some reason the gateway is offline and the devices cannot connect to it, then they're gonna retry every amount of minutes that you set it. So share my screen again. This is how you get it. You basically get with command 19. This is all in the documentation, and then you get the constant time 5. So let's see what is on the wiki that I use. So there have been a lot of messages because I set it to 1 minute. And this is, I guess, could be overflowing the network as well. Let's set it to 2 minutes with 0202 means 2 minutes. And then, by the way, you can actually append commands. So if you want to set the Keepalive and do something else. So in this case, it's 19, the command to check the network join retry period. I'm just going to type in 0202, so set the Keepalive time to 2 minutes, and then give me the network join retry period. Okay, so the message here is scheduled. And then if you want to set it, the command is 10, and you just set it. The default value is 3 minutes, but it could be even less, or yeah. Okay. We're gonna wait for that. It's gonna be a in about 20 seconds. So I'm gonna continue with the presentation. So what is child lock? Child lock is a very useful feature in case you want to use Vicki, for example, in a school where you don't want to really allow the occupants to control the temperature. So what happens is that whenever they try to turn the Vicki, they're not able to turn it. It's just what is on the presentation just shows CH, and that's it. So in order to get the status, you can actually get it from the Keepalive as well, but you can send a command, and then if you want to set it, then it's 07 and then 10 to enable the child lock, basically to activate it, and then 00 to disable it. So I actually want to try this one as well. Okay, this one it was confirmed, and then we received 1924. So 24. Let's get back a little bit. So it's seconds time 5. Okay. So we have 24 in hex. This is 36. As you can see, 36 seconds times 5. Times 5, it's 180. So exactly 3 minutes. Mine is on the default. Okay. And then let's check the child lock. I promised that. So we again go and send downlink, enable the child lock. I don't need the confirmed message right now, but yeah, we're gonna wait. But just to show you right now, I can adjust the temperature. Oops. So, okay, it's CH, and then I'm sharing my screen. As you can see here, the 07 passed. Some other commands from our server also were there, because I guess because I adjusted the target temperature. But basically, right now the child lock is enabled, and yeah, if we open this one as well, we can see that's true. And by the way, those scripts that you see to translate this row thing, payload, to this one, they're available from us. We've coded them ourselves. They're in JavaScript. We have a special one for TTM, but we have other one for obviously other systems. But yeah, that's good. So right now, if I try to repeat it, it basically says, I'm sorry, but you don't have permission to do it. So I really want to disable that because I really like setting different temperatures. So I'm going to send 0. I'm not sharing my screen again. I'm going to send 0700 and just send it. And then in a couple of minutes, I'm going to get rid of that. So let's continue with the presentation. Yes, we're on child lock. We're almost finished, by the way. I have only 6 more slides. So Vicki, you can also adjust the ranges of the target temperature, which are controllable through the Vicki manually. So if you have, for example, let's say it's a residential building and everybody in this building agrees that the maximum target temperature should be like 25. You can put this, and then nobody is going to be able to put it higher than 25. So to get the ranges, it's 15. It's going to be 5 to 30 because this is with the default setting. But then to set them, it's going to be 08. So let's really let's do this command. So basically, it says lower temperature minute, and the minimum allowed is the default value, 5 degrees, excuse me, and then the maximum allowed value by default is 30. But yeah, let's compose this command. So let's say I want to set it from 15 or no, even 12. So the first one is going to be 0C, and then if I want this to go to let's say 25, it's going to be 19. So it's going to be 080C 19. Let's see if I got this correct. Oh, so we see that we disabled the child lock here. Let's see if this command is to Wiki. Yeah, now I can control the temperature. And this is like demo. I'm not, it's not really staged at all. I just prepared the slides for this, but as you can see, I'm testing with you. So as I said, we want to set the target there, the temperature ranges between 12 and 25, which means we got to send the command 08, then convert 12 to hex, which is 0C, and then the upper limit is 19, which in hex is 19, but then in decimal it's 25. So we send this command, and now let's see what happens. Oh, it's actually already received. Can you see my screen? I don't think so. Okay, I keep forgetting to allow it, but I'm sorry. But okay, I set this command here. So it was scheduled, then it was sent, and then Wiki basically is just sending Keepalive. So I set it from 12 to 25. Let's see if this has happened correctly or I did a miscalculation. So I'm going down. Okay, 12 is the minimum, and then I'm going to go up. I don't know why the camera is not focusing, but okay. As you can see, those are the maximum and minimum temperatures. Really easy to also drive a certain behavior from your occupants. Could be an office, could be a residential building, could be a hospital even. But it's really easy to tell people, hey, it's not okay to put it to 30 because, I mean, we're trying here to be environmentally friendly, and 30 degrees is not something that is, even comfortable, I would say. Okay, I'm going to share my screen again. So we went through the temperature ranges. Okay, open window detection. I'm not gonna. I'm gonna tell you about it, but I don't think it's a good place to test it right now because I'm in a meeting room in our office. But basically, what open window detection does is, as you know, the radiators are frequently put next to the windows, obviously, for better convection. But this also allows us to kind of check if the window has been open, because we do have a temperature sensor, humidity sensor, and what the open window detection does basically, and again, it's configurable. I mean, we have our own default values, but you can set whatever you wish. But it basically, for a set period of time, which is hard-coded by us, this you cannot configure. Every minute, it compares the temperature of the last measurement with the current measurement. And if the temperature drop is too high, then it's going to effectively do something. And what is something you define? It could be closing the valve fully. It could be closing it halfway even. But then you can play with those values. You can decide whether you should put it halfway or fully closed. It should be like 2 degrees or 1 degree. But basically, you can, another thing that you can control is the duration of this period where there is an open window detection. So if somebody opens the window, the Wiki detects that. And then the default period, I believe, is 20 minutes that it fully closes the valve. But if you want to put it like 5 minutes, for example, or perhaps, I don't know, more, it's up to you. Really configurable based on the application. You can do that. and also the temperature difference, how fast the temperature drops. Obviously, you can control it. I'm not gonna demo that, but here are like the commands. Basically, how you get it. It's command 13, and then you get is the open window detection functionality enabled or disabled? So do we keep track of that? What is the duration? And what is the position of the motor that you have to, that Vicki is going to go whenever there is an open window detection. And here we also have because the position, it usually needs more bytes, doesn't fit into a single byte. So there is another byte here, which is the MSB or LSB. I'm gonna lie to you, honestly. You gotta take a look at the documentation, but again, the motor position and the temperature difference that needs to be achieved. And this is how you set it. I mean, it is almost the same, because I've definitely copied the same table again, but okay, let's go to the documentation. So I'm going to look for open window. Okay, get open window, it's 13. And then it's usually set open window. Here it is, it's 06, so I've lied to you. I'm gonna fix the flights. I'm gonna share them as well. But yeah, this is how you enable it and set the duration to 20 minutes and the motor position 540 steps, the temperature delta to 3 degrees. So, okay. And then okay, those are the last two slides. I'm gonna go really quickly over them, but so recalibration, there is a specific command that basically forces Vicki to discover if there has been if the motor range has changed. So you can use that in case that the Vicki is not fully closing the valve. Although this happens in really rare cases. It happened more in the beginning when we were not as knowledgeable about all the valves, but right now we believe we covered all of them. I mean, we're in so many countries and so many homes that I do believe so. But if you want to recalibrate a motor, so basically figure out the new target motor position and motor range, you can do that by the recalibration function. I don't recommend you to use it because it's draining battery, but I mean, as I said, we're trying to make the devices really configurable. I cannot test this function right now because I don't have an outside mic with the headphones, so you're not gonna really hear the motor calibrating, but feel free to test it. And the force close. The force close, it's again a safety function, doesn't really need to be used. I mean, if you're having overheating problems in your building, I suggest you check basically the control curves of the central controller, the heat controller in the building. Because from our experience, this is where some problems are coming from. But if you really, if you touch the radiator after a couple of hours, once, Vicki, you've set, for example, the target temperature to, let's say, 5 degrees, and there is still some water, you hear it there, you can do the force close. You can try it. What is basically going to do is it's going to exert more power on the shaft of the valve, so that it, just close it fully. But in the meantime, it could be, for example, some clogging of the pipes there. So, I mean, I encourage you to use it, but if you see that this is solving a problem of overheating, I first recommend you to check if everything has been mounted well. And if it's still solving the problem, then reach out to us, because we definitely have to see what is happening there and you know, perhaps there is a rare case that we haven't discovered. But let me finish with the slides. So currently, Vicki is used by many people. I mean, we've manufactured tens of thousands of devices. They've been installed in all kinds of buildings, and we're thankful to our partners for doing so, because we're developing the devices, putting a lot of thinking into that. But we definitely need now our partners to do the groundwork to also convince the people that with something as small as that, as and simple as just turning the knob, and with some schedules before that, buildings can save a lot. So the buildings that use Vicki save on average between 15 and 30%. I would say that it really depends on from what kind of installation are you coming. So if you're coming from lock shield valves, you're going to be saving way more, perhaps 50-60%. If you're coming from TRVs, then it's between 15 and 30. But then again, it's about behavior, about basically the rules that you set, the schedules, because at the end of the day, if you make the right schedules, then you're going to be able to achieve some great savings, perhaps above 30%. And then in the meantime, you have a device which has about 10 years battery lifetime, which you're not going to be changing for a long time. So it really makes the lives of people either in the office, in the how do you call this in English? In the hospital, really takes your mind off some things like, hey, did I actually turn off the heating when I was going out? And this could be applied to residential buildings. Most of the buildings that we have are residential. Whole building filled with not those Vickis, not the LoRaWAN Vickis, but our own proprietary protocol. But essentially, it's they're generating savings between 15-33%, which is just great. And I believe that this is basically the technology reached the level where you can use this, radio communication, etc., protocols to achieve some really significant savings with installing a single gateway or two gateways if it's a really big building, or 3 gateways. But it's not like you're going to be installing something which is Z-Wave or Bluetooth, because then you're going to be needing about 100 or 150 gateways. And I mean, those technologies are also operating in the same radio frequency. It's just that LoRaWAN is able to achieve better communication range. So it can communicate to gateways further away, and in the meantime, it can go better through walls. So now I'm gonna finish the webinar with that. I hope that you enjoyed it. I know that it is now almost an hour and a half. But if you have any questions, definitely take a look at the documentation. And also, if you need any support, we from MClimate are willing to help. So you can drop us an email. You can, if we have an ongoing cooperation, then we can also create a live support in Slack. But we're really flexible about that. We know that we've created a great device that we know that now, after a couple of heating seasons, we know that the savings are there, the performance is there. So we're willing to share all the knowledge that we have and really make you experts in that, and so that you can help your customers, you can help your buildings to achieve better energy efficiency and not waste so much energy. And then in the meantime, just we've been talking about IoT, about smart home cities, buildings for so long, but the thing is, this technology is not here. It's been here for a couple of years, but trust me, as an entrepreneur from 2000, we started the company in 2014. I mean, the market was different. Right now, there are a lot more willing people to, and they recognize the upsides of having something like that, or like the AQI sensor, and just make their daily lives better. And in the meantime, feel more comfortable having Vicky caretake of the temperature, and also be happy because of lower bills. Okay, guys, it was nice meeting you again. My name is Ljubomir Janchev, and feel free to reach out to us. Bye bye.